Welcome to section 9.5, day 1, completing the square. Today's objective is to solve quadratic equations by completing the square. So we're going to do a little review. Remember when we factored back in chapter 8? We've done some more here in chapter 9. And like it says at the bottom, it says, what are these kind of trinomials called? And hopefully you'll recognize that x squared plus 6x plus 9, and then 4x squared minus 20x plus 25, these are perfect square trinomials. And when we factor a perfect square trinomial, we get a binomial squared. What's the square root of x squared? X. What's the square root of 9? 3. What's the sign in the middle? Positive. This becomes a binomial squared. When we look at the second one, we have 4x squared minus 20x plus 25. We take the square root of the first, which is 2x. We take the square root of 25, which is 5. We take the sign in the middle, which is negative, and we get 2x minus 5 squared. If you want to verify these are actually perfect square trinomials, if you multiply the two terms together and double them, you should get the middle term. So if the first one, we have x times 3, which is 3x, doubled is 6x. For the bottom one, we have 2x minus 5. We multiply it together, you get 2x times negative 5, which is negative 10x. Negative 10x doubled is negative 20x. So these are indeed perfect square trinomials. And when we factor them, they become binomial squareds. We're going to use this today to do what we call completing the square. So here it says, not all quadratic equations can be factored, but there are ways we can still solve these equations, and we're going to learn one of them today. For an expression of the form x squared plus bx, you can add a constant c to it so that you get x squared plus bx plus c becomes a perfect square trinomial. And this process is called completing the square, because what we're doing is we're adding a squared term. So we're completing a square. So to complete the square, we take the middle term, that b value, divide it by 2 and square the results. And this gives us our c. So one of the things we're going to be doing today is finding the c value that would make a perfect square trinomial. And then we're going to also solve some when we have an equation. So here it says, find the value of c that would complete the square and write the answer as a perfect square trinomial. So if the first one, we have x squared plus 8x plus c. We want to find the c value. And the c value is the b divided by 2, and our b here is 8 divided by 2 all squared. And this will give us our c value we want. 8 divided by 2 is 4. And that's all squared, so c is 16. So we're going to put our 16 in place of c. And we got x squared plus 8x plus 16. And this is now a perfect square trinomial. And we can factor that later into a binomial squared, which we'll be doing later. The next one we have is x squared minus 12x plus c. We want to find the c value. And again, our c is our b, which in this case is negative 12. Divided by 2, all squared. So our c is negative 6 squared, which is 36. So we're going to put this in for c. So we got x squared minus 12x plus 36. And we have created a perfect square trinomial. This is what we'll be doing today for part of our assignment, and then we're going to do the other part, which will be solving. So remember that part, for finding the c, it's the middle term, the b value divided by 2 squared. And that will give us our c we want to add to create this perfect square trinomial. It says, why do we complete the square to solve quadratics? Like I mentioned, by completing the square, we can factor the perfect square trinomial into a binomial squared. And when we have that, we can use the square root property to solve the equation. Hopefully you remember the square root property from 9.4 day 1. So when we complete the square in an equation, we must add the c value to both sides of the equation. On the last slide, we just had expressions for finding c. If we have an equation, whatever that c value is, we must add to both sides of the equation. It says solve the equation below by completing the square, and then round to the nearest tenth if necessary. Right now we have m squared plus 16m is negative 59. So we need to find a constant to add to the left side that will make it a perfect square trinomial. So we need a c value to add. And we get c is the middle, the b, divided by 2, which is 16 over 2, all squared, which is 8 squared, which is 64. From here, we're going to add 64 to both sides of our equation. And now we have m squared plus 16m plus 64 equals negative 59 plus 64. Notice we add the 64 to both sides of the equation. All right, the next step we do is we are going to do two things at once. We have created a perfect square trinomial on the left, and then we're going to add the numbers together on the right. We're going to factor the left side, and there's two ways to look at this. One is we know we have a perfect square trinomial, so we can take the square root of the first and the square root of the last and put the sign in the middle. That is one way. So we have m plus 8 all squared. And this is going to equal negative 59 plus 64 is 5. You'll notice the 8 squared that we had when we found C, the 8 is the same number that gets plugged into our binomial. So when we take the b divided by 2, that number we find before we square it is what goes in the binomial when we factor the perfect square trinomial. So when we found our C value, we had 8 squared. The 8 is what comes into our binomial. Now that we have this, we have a squared term equal to a number. We can now use our square root property. If we take the square root of both sides, the square root and the squared term, they cancel each other out, just leaving the m plus 8. And then we have plus or minus the square root of 5. And then we're going to solve for m, so we move the 8 over by subtracting it from both sides. And we get m is negative 8 plus or minus the square root of 5. On a lot of your assignment today, it's going to ask you to round to the nearest tenth. Quite often, you're going to be asked to round to the nearest hundredth. So remember, the tenth is the first decimal place, the hundredth is the second decimal place. So we have to set up two things. We do m equals negative 8 minus the square root of 5, and we do m equals negative 8 plus the square root of 5. Because of that plus minus, we need to do both of these. And when you do this, you'll find that m is negative 10.2 for the first part. So negative 10.2. And when you do the second one, when you have negative 8 plus the square root of 5, you get negative 5.8. These are my two solutions. All right, these are not exact answers. We'll ask you to round. So if it asks you to round, you round. If it doesn't ask you to round, you would leave it just like this. But once it says to round to a number, we'll round to whatever value it asks us to. Okay? The one on the left, that m equals negative 8 plus or minus the square root of 5 is the exact answer. And then m equals negative 10.2 and negative 5.8 are estimated answers, are rounded answers. Only round when it tells you to. Here it says solve each equation by completing the square and round to the nearest tenth if necessary. So the top one, we have x squared minus 2x equals 3. It's already set up for us. We have the x squared and the x term by themselves on the left side of the equal sign equal to some number. So we can go right to finding the c value. Our c is our b, which is negative 2 in this case, divided by 2 squared, and this is negative 1 squared, which is 1. So we need to add 1 to both sides of our equation. So we have x squared minus 2x plus 1 equals 3 plus 1. And now we have a perfect square trinomial on the left, and we can factor this. And what's sort of nice, like I said before, if you remember how to factor, it's easy. Square root of the first, square root of the last, sign in the middle. Or you can look at what we found for our c. When we had that negative 1 squared, the negative 1 is what goes in our binomial. You can look at it either way. All right, now we have a squared term equal to a number. We can now take the square root of both sides using our square root property. So now we have x minus 1 equals plus or minus 2. We move the 1 over by adding it to both sides. And we have x equals 1 plus or minus 2. And we have x equals 1 minus 2, x equals 1 plus 2. And then we have that x is negative 1 or x is 3. These are my two solutions, -1 and 3. The bottom one, we have m squared plus 10m plus 8 equals 0. This one is not set up yet for us. Notice that we have a constant on the left side. When you look at this one, you can't factor it with 8 there. Nothing multiplies to 8, that adds to 10. So we need to move the 8 over first. So we're going to move it over to the other side so we can make room for our new c value we're going to use to complete the square. And when I write these, what I usually do is I put a placeholder in so I don't forget that I need to add it to both sides. When we find our c value for this one, we take half of b again, which is 10 over 2 all squared, which is 5 squared, which is 25. So we're going to add 25 to both sides of our equation, because whatever we do to one side, we must do to the other. The left side is now a perfect square trinomial. Square root of the first is m, square root of the last is 5, sign in the middle is plus, all squared is 17. And again, you'll notice that the number that's in our binomial is the same number as half of b. Now we can use our square root property, take the square root of both sides, and we get m plus 5 equals plus or minus the square root of 17. This leads to two equations. We're going to subtract 5 from both sides first, though. So we get m equals -5 plus or minus the square root of 17. Now we have our two equations. M is -5 minus the square root of 17. M is -5 plus the square root of 17. And when you do these on your calculator, you have -5 minus the square root of 17 is -9.1. When you have -5 plus the square root of 17, when you round to the nearest tenth, you get m is equal to -0.9. These are my solutions. Again, these are asked to round to the nearest tenth. So round to the nearest tenth. If I ask you to round to the nearest hundredth, round to the nearest hundredth, which is the second decimal place. All right, so here's some examples of completing the square. Always make sure you have the x squared and the x term by themselves on the left before you do anything else. So here you have r squared minus 4r equals 30. I want you to try this, complete the square. So first, find your c term by taking half of b and squaring it. Add that number to both sides. Factor your perfect square trinomial. Then use your square root property, and you will get two solutions. Please pause your video and see if you get the same thing I do. Well, first, our c is half of the -4 squared. This is -2 squared, which is 4. We're going to add 4 to both sides. So we have r squared minus 4r plus 4 equals 30 plus 4. The left side is a perfect square trinomial. So we can take the square root of the first, square root of the last, sign in the middle, all squared. We add 30 and 4 together, we get 34. We now have a square equal to a number. So we have our square root property we can use, take the square root of both sides. And to get r minus 2 equals plus or minus the square root of 34. Add the 2 to both sides. And it's customary to put the 2 out front like this. 2 plus or minus the radical, 34. And you're going to have two equations. R equals 2 minus the square root of 34. And r equals 2 plus the square root of 34. Then when you do these on your calculator, you should get -3.8 for the first one. And you should get 7.8 for the second one. These are my two solutions. All right, that was all for section 9.5, day 1. Today we are starting to complete the square. So when we went through the notes today, you have to find a c value that you can add to both sides of an equation to make a perfect square trinomial, which can then be factored in a binomial squared, and then we use the square root property. Make sure you're showing all your work. I'm expecting to be able to do this when you do your quiz and test by using all these steps, and I expect to see all the steps. Thank you for watching and have a nice day.